In this video, we'll look at a couple tools to make more effective visualizations. First, let's look at a couple more types of plots. Pie charts can be effective at showing how multiple pieces can make up the whole. We'll make a new figure, plt.figure, and let's take a list of weights. We'll call it nums, and we'll use 20, 25, 40, and 10. And then we can make a pie chart for them. plt.pie of nums produces a pie chart. We can add labels with a second list. We'll call it labels, and we'll say these are actually numbers of animals: cows, pigs, horses, and chickens. And say that labels equals the variable that we made for labels. We can also make a variety of 3D plots, but I'll demonstrate 3D scatter plots since they're fairly simple. We need to add another import first. From MPL toolkits.mplot3d import axes 3D. To make a 3D figure, we create a new figure as usual, plt.figure. And then there's an extra step to take to make it 3D. plt.subplot 111 and then projection equals 3D. And now if I do a plt.scatter, I'll have to specify the values for all three axes. I'll just fill this in with a Gaussian ellipsoid. Notice that for the third argument, I had to specifically call this z's, so it would know that this is the third axis to use. And then I also specified the point size as 4. And now we can see all of these points plotted in a three-dimensional space that we can rotate. Let's get back to 2D plots and look at the axes in a bit more detail. Here's a scatter plot from the previous video. If we want to change the range of values shown, we can use xlim and ylim. So plt.xlim and then specify some values. Let's make this go from -10 to 20. And then we can also play with the y values. plt.ylim will make it go from -1000 to 10,000. The default ranges are usually pretty good. In fact, I've made this plot worse by doing this, so I'll comment them out. But notice that it's hard to tell what some of the smaller y values are. They all just seem to be the same. To make this easier, let's switch the y-axis to use log scale. plt.yscale log as a string. And now we can see that this appears to be a straight line. I'll make a couple different versions of this data, each one slightly different. Let's make y1 and y2, where y1 is 100 times larger, and y2 is a fixed amount subtracted away, let's say 1000. And then let's plot these other two lines with y1 and y2, and we'll take these colors out so matplotlib can decide what to color them itself. And these are our updated points. By default, matplotlib should plot them in different colors, but we still can't tell which one of these is which. To do that, we'll need a legend. First I'll go in and give each one of these a label. I'll say that this one is the original. This next one is larger. And this one is smaller. And then I can tell matplotlib to give us a legend with plt.legend. We need the parentheses to call the function, but we don't need to put anything inside. And now we can tell which one of these is which. I would recommend adding a legend to almost any figure with more than one set of data plotted. Finally, let's look at changing the font. We can do this with plt.rc, which allows you to change a lot of different settings. First, we'll tell RC that we want to modify the font, and then we provide it a list of settings that we want to change. In this case, let's make the size 14 point. Let's make the weight bold, and let's make the family monospace. And here's our resulting plot. You can tell the font is definitely different from what it was before. But be a little bit careful with RC. I believe this will take effect beyond just this one figure. Hopefully these tools will give you more control over the design of your plots.